My name is Jill Tarter, and I'm the Bernard M. Oliver Chair for SETI at the SETI Institute in Mountain View, California. I've been involved in SETI for my entire professional career. It didn't start out that way. It was actually an accident because I was the only one that knew how to program an ancient computer that was given as surplus equipment to a professor who wanted to start a SETI search. Science as a career is phenomenal. And you know, when we talk to students, I think most of the time we forget to say the really most important thing, which is being a scientist is fun. Being able to try and answer questions that nobody has an answer to yet. You could be the first one ever to figure it out. And the other thing about being a scientist, and we forget to share this, is that you never have to grow up. You never have to stop asking why. Why this and not that? What if? It's great. It's a wonderful career. You won't get fabulously rich, but you will be rewarded by being able to work on things that mean everything to you. My undergraduate degree is in engineering physics, and then I went on to graduate school in astronomy at UC Berkeley. And it was a perfect match for SETI because not only did I have some understanding of how the universe works and what natural sources of signals are, but I also had the engineering background and knew how to build things, or at least knew how to detect, the BS from young engineers who were saying, oh, we could do this, when indeed we couldn't. But in fact, with perseverance, we eventually managed to do the phenomenal kinds of signal detection that we had envisioned. I don't have any formal training in biology, although I am part of a larger community of astrobiology. I sit and listen and learn from my biological colleagues. And at the SETI Institute, we have over 150 people who are scientists working on this "are we alone" question, but only a handful are looking for the intelligent end of the spectrum. The rest of my astrobiology colleagues are looking for signs of life, microbial life, or conditions where life, perhaps even life as we don't yet know it, could exist. So I look for the mathematicians. Most of my colleagues are looking for microbes. Understanding how we came to be, what the origin and evolution history of life on this planet as we know it actually is fundamental. And it's really hard as we try and trace our long history and understand what happened to go from the cyanobacteria that produce the oxygen in the atmospheres that we breathe to our big 3.5-pound brains. It's really hard with an example of just one to figure out what's necessary and what was contingent. So I like to tell students particularly, if we still had prehensile tails, right, like the monkeys, we would have a story that convinced us that having such a tail, in addition to 2 hands, was absolutely fundamentally required for having a big brain. Okay, again, because we only see what happened here. We don't really know how it could have happened another way. So looking for life elsewhere, understanding the limits of biology elsewhere, will very much help us to understand in a deep way biology as we now know it. The question of whether there's life beyond Earth is one that has fascinated humans forever. I actually only look at that from a scientific perspective because I really understand that it doesn't matter a hill of beans what I believe. There is an answer to the question. There is life somewhere else or there isn't. And I, as a scientist, am really intrigued with finding out the answer. That's much more important than my hunch, my gut feeling, my belief. That means nothing. The question is there, it's a legitimate question. Let's go find the answer. I had no idea when I started as an undergraduate student, as an engineering student, what I would end up doing. I don't think I even thought enough about what it meant in terms of preparing for a future. I was doing something I loved. I was getting a really good education. I was learning a lot of math, some electrical engineering, and I just understood that what I should do is develop tools for solving problems, and then as time went on, go figure out what the interesting problems were. And I was really lucky. I fell in love with the idea of working on SETI, of working on something that humanity had been asking itself questions about forever. And I just ended up being at the right place, the right time, with the right skills to do something about this question. I got hooked as a graduate student. I've stayed hooked. I think what we're doing is incredibly important, and in fact, is an investment in the future of our planet.